In November 1919, newspapers across Europe and America suddenly had a new scientific celebrity, Albert Einstein. A solar eclipse had provided evidence supporting his revolutionary theory of gravity, and the unknown physicist was suddenly famous. Just 15 years earlier, Einstein had been working as a patent clerk in Bern, Switzerland, struggling to find an academic position. While examining other people's inventions during the day, he spent his free time thinking about one strange question. What would happen if you could travel alongside a beam of light? But Einstein's story began much earlier. Albert Einstein was born in Ulm, Germany, in 1879. As a child, he was fascinated by mathematics and physics, but he disliked memorizing rules without understanding them. When he was about 5, his father gave him a magnetic compass. Einstein was amazed that the needle moved, even though he couldn't see what was making it move. That invisible force stayed with him as an idea. There were hidden rules behind the things we could see. As a teenager, Einstein became deeply interested in mathematics, physics, and philosophy. His family moved to Italy, and he eventually studied mathematics and physics at the Swiss Federal Polytechnic in Zurich. He graduated in 1900, hoping to become a university teacher. It didn't work out. University positions were difficult to find, and his applications went unanswered. Einstein took temporary teaching jobs until, in 1902, a friend helped him obtain a position at the Swiss Patent Office in Bern. It wasn't the career he wanted, but it gave him something valuable: time to think. Einstein became a skilled patent examiner. During the evenings, he discussed science and philosophy with friends Maurice Solovine and Conrad Habicht while working privately on the problems that interested him most. And one problem kept returning: light. Einstein wondered what the universe would look like if an observer could move almost as fast as light. The question eventually led him toward a radical possibility. Perhaps the problem wasn't light. Perhaps our understanding of space and time was wrong. Then came 1905. Einstein was only 26 years old, still working at the patent office, when he published several papers that transformed physics. One explained Brownian motion, providing important evidence for the physical reality of atoms. Another proposed that light could behave as discrete packets of energy. This work explained the photoelectric effect and would eventually earn Einstein the 1921 Nobel Prize in Physics. Then came his theory of special relativity. For centuries, people had assumed that time passed universally for everyone. Einstein showed that this wasn't true. Measurements of time and distance could depend on an observer's motion, while the speed of light remained constant. There was no single universal clock ticking identically throughout the universe. Later in 1905, Einstein also published the famous equation, E equals sine mc squared. It showed that mass and energy were closely connected. At the time, it was simply a consequence of his new physics. Decades later, the equation would become closely associated with the nuclear age. Einstein's reputation slowly grew, and he eventually moved from the patent office into academic positions. But he wasn't finished. Special relativity had changed our understanding of space and time. Now Einstein had to solve another enormous problem: gravity. Newton's theory of gravity had worked brilliantly for more than 2 centuries. Einstein believed, however, that gravity had to fit into his new understanding of space-time. For nearly a decade, he struggled with the mathematics. By 1915, Einstein finally completed his general theory of relativity. Its central idea was revolutionary. Matter and energy affect the geometry of space-time, and objects move through that curved geometry. Gravity was no longer simply an invisible force pulling objects across space. But Einstein needed evidence. His theory predicted that the sun's gravity should bend the path of light passing near it. A total solar eclipse offered a way to test the prediction because the darkness would make stars near the sun visible. On May 29th, 1919, British astronomers, including Arthur Eddington, photographed stars near the eclipsed sun. Their measurements supported Einstein's prediction. The scientific result was extraordinary. The public reaction was even bigger. Newspapers around the world announced that Einstein had challenged Newton. The man who had recently been an obscure patent clerk was suddenly one of the most famous scientists alive. But Einstein's life changed again in 1933. Adolf Hitler came to power in Germany. Einstein, who was Jewish, was abroad when the Nazis seized power. His home was searched, his property was confiscated, his books were burned, and he was openly targeted by the regime. Einstein never returned to Germany. He eventually settled in Princeton, New Jersey, joining the Institute for Advanced Study. Then came another scientific crisis. In the late 1930s, scientists discovered nuclear fission. Physicist Leo Szilard feared that Nazi Germany might develop a nuclear weapon. He approached Einstein, and together they sent a letter to President Franklin D. Roosevelt warning the American government about the possibility. Einstein himself did not work on the Manhattan Project. When atomic bombs destroyed Hiroshima and Nagasaki in 1945, however, the consequences of modern physics became painfully real. Einstein spent his later years advocating against nuclear weapons and for international cooperation, but science remained his obsession. In Princeton, the elderly Einstein continued searching for a unified theory that could connect the fundamental laws of nature. He filled notebooks with equations and continued working even when many physicists had moved in other directions. He never found the answer. On April 18, 1955, Albert Einstein died in Princeton at the age of 76. The world remembered the wild hair, the famous equation, and the word genius. But Einstein's story had started much more simply. It began with a 5-year-old boy holding a compass and wondering about an invisible force. Decades later, the compass had become light, space, and time. Einstein spent his life searching for the hidden rules behind the universe. And perhaps that was his greatest gift. Not simply the answers he discovered, but the questions he refused to stop asking.